try not to trip over anything. So, good morning, everyone. Some of you have heard me speak before, so you know that I'm open to questions as we're going along. I know there's some folks online, so that might be a bit difficult, but I'm Alison Robertson. Thanks to Eric for inviting me up here today. And Eric asked me to talk about Southern Rust. You had been at my presentation in early December.
I saw the one in Mason City.
Oh, you saw the one? Okay,
yeah.
okay. And so it's basically the same presentation, but it's nice to have a small group because we can stop and discuss things going on. So, yeah, should you spray or should you go fishing? That's basically what we're going to talk about today. So, we'll talk about Southern Rust in Iowa in 2025. I just want to go over why I think Southern Rust was so severe here. And then I have some fungicide trial data. I also want to talk about return on investment because I think that the corn prices as they are now, that's something that you should be thinking about if you're going to make a fungicide decision, right? And then there are a lot of tools that are available for fungicide decisions available on the Crop Protection Network. Have you guys heard of that? And so I just wanted to go over some of those that I think would be useful for you. So we won't worry about that. So first of all, it's important to know what disease is occurring in our field, right? And how to identify this. So these are just some pictures of diseases that you might expect to see around about tasseling time. And it's important to be able to recognize those diseases. So this is Southern Rust on the upper and lower surface. We always look on the upper and lower surface. And you'll see that on the upper surface, we have like a cluster of probably 50, 60 tiny little blisters, right? Which are kind of bursting. And when they burst, then those orange spores come out, right, of the Southern Rust. We see that on the top of the leaf, but if you turn the leaf over and look at the underside, those blisters don't break through on the undersurface of the leaf. They're just on the top surface of the leaf. So it's kind of a clue that you've got Southern Rust. That's different from common rust because common rust will have the, blisters on the top side and on the bottom side of the leaf. And the other thing, if you look at common rust, right, can you see how we don't have this like big cluster? It's more like this rectangle, and then within that rectangle shape, you'll see those little blisters, right? Can be mistaken for gray leaf spot because gray leaf spot is also kind of rectangular. So what you'll want to do is just hold that up to the light and see if you can see those little blisters in it. And then tar spot, right? I think most of you know what tar spot looks like. The biggest thing with tar spot, especially early on in the growing season, is you want to, if you see a little spot like this on the surface of the leaf, turn the leaf over and look on the underside. Can you see the black spot on the underside as well? If you can, then you know that's tar spot. That black spot is kind of like a mini sclerotia that's buried in the leaf tissue, and that's why you can see it on the top and the bottom. If you only see it on the top, then it might not be tar spot, it could be bug poop. And sometimes bug poop can be hard to wipe off the leaf, right? And then northern corn leaf blight looks that elliptical lesion, even when it's really early coming on, you can still kind of see that cigar shape. Okay, so, disease cycle. Really, the important things here is just that it's the orange spores that infect the corn, and we need warm conditions, and then that leaf needs to be wet for at least 6 hours. In actual fact, that's taken from an extension publication, and I think that should be more like 10 hours. I'll show you some data later on that. And then remember in the fall, as that corn matures, the fungus that causes Southern Rust stops producing those orange spores and it starts producing these black spores, which are covered by this, like, don't really break through. So here's the orange spores. You can see them bursting through, right? And then the black, it's kind of covered. So those black spores can't infect corn, right? And so the important thing about that is that those southern rust orange spores cannot survive for more than a few days. And so they're not going to survive over the winter, right? And that means that those spores have to be blown up to us every year. So this is one of the diseases that doesn't survive here in Iowa. Normally I take that slide off. Yeah, these are the black spores that are produced compared to those orange spores. Okay, so these are first reports of Iowa, southern rust in Iowa since 2021. But if you go back further, you'll see, I mean, I've been here 22 years. I would say I've seen southern rust 20 of those 22 years in Iowa. So it's not a surprise to see it here. It's just the surprise was last year where it was so severe. And what you'll notice about last year in 2024 was that the rust came in the middle of July. Before that, we'd had rust at the end of July, but most of the time we tend to see it come in kind of the middle of August. So why was southern rust so bad? So I like to talk about the disease triangle. Remember, a disease can only occur if we have all three factors present, right? So we'll start, the three factors are pathogen, host, and environment. And I always start with the host, right? So if we look at the corn plants here in Iowa, so this is a picture taken at a demonstration plot in central Iowa. But I think you can clearly see that the hybrid on the left has a lot of southern rust compared to the hybrid on the right, which is much more resistant. So hybrids are going to vary in their susceptibility to southern rust. And, oh, there we go. There's a close-up of that. So you can see this hybrid on the left, right? I hope you can see that. Maybe a bit hard at the back, but you can see it's not as green, as healthy as the hybrid on the right.
The one on the right is the cow, right, Matt? Exactly.
Definitely. Absolutely, yes. Yeah. Both from the same company, and not from DeKalb and not DeKalb or Pioneer Corn, so another company. Okay, so the fungus that causes southern rust, this is its fancy Latin name, which is really not that important. So remember, I told you that pathogen can't survive here in winter, right? So it blows up to Iowa from Central America every year, where they're growing corn the whole year round, right? And it blows up on something called the Puccinia pathway. So all rusts, if you grow wheat, oats, soybean, that all those rust spores are going to come up on that pathway. So, and then what will happen is they'll either settle out of the atmosphere, or you'll get these heavy rains that just wash the spores out of the atmosphere and into the crop. So what was different about 2025? This is a map that shows corn for grain production in 2024, okay? But you'll see these numbers on here. That's the increase in acreage planted to corn in the southern states. So in Louisiana, in 2025, they planted 75% more acres of corn than they did in 2024. Okay, Louisiana, 42%. Mississippi and Alabama, 22%, right? So one thing about 2025 is we had a huge increase in the acreage of corn down in the south, right? So you can imagine if we have more corn there for those spores coming in from Central America, there's more host, right, for them to infect. And then another thing about in 2025, a lot of the farmers there chose not to spray a fungicide because of grain prices. So we had more acres and less of those acres were sprayed. So that just means that there was a lot more inoculum that could come up to us. And then another thing about 2025 is if we look at the windroses, we'll see, first of all, that most of the wind in 2025, we had a lot of wind coming from the south, okay, compared to 2024 where it was kind of southeast, 2021 kind of southwest, okay, so directly from the south, coming up from those 75% more acres in Louisiana, 40% more in Arkansas. So we had more, and then if you see from the windrows, that orange and red is the strength of the wind, and so basically we had more winds from the south, and they were stronger, bringing more inoculum from the south up into Iowa. Of course, when the spores get here, they have to have the right conditions to infect, right? So one thing that I've learned from being at Iowa State is that it doesn't matter how many spores you put onto corn, if it's not susceptible and you don't have the right conditions, you will not get disease. Every year, I try and get disease, right? So we inoculate trials to get disease. I inoculate demonstration plots so that I can teach people how to recognize those diseases. And if it's hot and dry, it doesn't matter how many spores I put on there. I'm not going to get disease. So we had all these spores coming here, but what was unique about the weather? Well, first of all, we had a ton of rain, right? Especially you guys up here. So 13 to 19 inches, right? I don't have that. Sorry, I have so many variations of this presentation that every now and then I'm like, oh, this one doesn't have that slide in. Okay, but yeah, so a lot of rain, and I want to say that the year before you probably had about a third as much rain, right? You were probably sitting at about 6 inches for 1st of July through August, if I remember correctly. So what I did was I really wanted to know, why was southern rust so bad in 2025 compared to 2024? And so I went and I got the data from the agronomy farm in central Iowa, right? And this graph here shows the precipitation amounts from the 1st of July until the 30th of August, okay? In the dark blue bars, you have 2025. The very light blue bars are 2024. But if we look at the summary table, first of all, you'll see that in 2025, we had 3 times as much rain as in 2024. Okay, so a lot more rain. Even though 2024 had more days, double the amount of days of precipitation, this is like piddly little precipitation, right? 1/10 of an inch here, 2/10 of an inch there. Whereas in 2025, we had 12 days where we had very, very heavy precipitation, over 1/2 inch of rain. And so that would have contributed to a lot of moisture being around. If we look at the temperatures, so the red bars are the daily highs, and the pink line that you can see is the average for the last 30 years. And then the blue lines are the daily lows, and the light blue line is the 30-year average. And you'll notice that a lot of those bars are above that line, right? Indicating that we had warmer conditions than normal. So I looked at the temperatures at the same farm and compared them for 2025 and 2024. So we have the number of days that were higher than the average, the number of days that were lower than the average, and then the number of days where the low was greater than 70 Fahrenheit. Southern rust prefers very warm conditions, so it kind of like 75 to 82, 85 Fahrenheit, right? So this is why I looked at that greater than 70. And what you'll see is that in August, it's all pretty similar. But in July, we had almost a week of more warmer weather, right? So I always struggle with how I'm going to say this. But so in July 2024, half of those days in July were above normal temperatures. In July 25, 3/4 of those days, so 21 of those 30 days, 31 days in July, were warmer than normal, right? So very warm conditions, very, very wet. I talked about how leaf wetness is important. So on this work that was done 30 years ago, we have the number of pustules on the vertical axis. So the more pustules, the more severe the disease, right? And then along the bottom, we have the temperature in Celsius. So 16 Celsius is 61 Fahrenheit, and 28 Celsius is 82 Fahrenheit. But these are the temperatures that occurred during that July period, right? And you'll see that as the temperature increases and the periods that the leaf are wet increase, we get more and more pustules on the leaf. So one of the PhD students at Iowa State made this chart for me where we looked at leaf wetness during July at that Boone farm. And what you'll see is that in 2025, those leaves were wet for 1 to 3 hours longer than they were in 2024. And those leaves were wet for, 12 to 14 hours. So we had a lot of leaf wetness there. So basically, if we look at the disease triangle and why we had such severe southern rust in 2025, susceptible hybrids on the landscape, more inoculum and more and stronger southerly winds bringing that inoculum, okay, because of the increased acreage in those sprays. And then once that inoculum arrived here, we had above normal precipitation. It was very heavy, so that led to more those leaves being wet for longer. And then we had above normal temperatures. So I think that's the reason why we had such severe southern rust. So the question is this going to happen again in 2026?
Hope not.
Yeah, I don't think so. I mean, I think that we're probably still going to have more inoculum coming up here, right? Because we're still going to have more acres down in the south because cotton prices are pretty bad. So farmers are planting corn instead of cotton. Farmers are, if they didn't spray last year with last year's prices, they're definitely not going to spray in 26 with the prices as they are now. So it's just a case of when the spores get up here, are we going to have the moisture and the temperatures? And I think we might have the temperatures, but I'm not sure that we're going to have 3 times as much precipitation than normal, right? So,
Alison, where would be like the tipping point potentially? So as you see, as we watch next year's weather, right? We start seeing like 7, 10 days of some of these similar things. Like, oh, we really need to start thinking about it, or do we have the benefit of scouting southern Iowa and just listening to what those people are seeing?
yeah, so that's one of the tools. It's a good question, Stuart. But one of the tools that's available on the Crop Protection Network is that map, right? So you can see where people are reporting southern rust. And yeah, I mean, maybe in the south they don't report it as much as we might do up here in the north, right? Because it's just whatever, they see it anyway. But we'll at least have an idea that it's there. And so, I mean, Darren and I tend to watch what's going on in the south. We also have all the corn pathologists in the US. We have a meeting once a month where we talk about what we're seeing in our states. And so we kind of keep each other updated on what's going on. So, yeah, I mean, it's that just a case of keeping an eye on where it is, keeping an eye on the weather. So I would say if we're having above normal precipitation, that you should be concerned for southern rust. And I'll talk a little bit, another tool that we have are disease prediction models. We don't have one yet for southern rust. We have tar spot, gray leaf spot, and vomitoxin. but hopefully that southern rust will come in the next 18 months, the model, and then we'll be able to use that. But yeah, but to like, just based on what I saw in 2024 and 2025, because I had a field in 2024 where we had really severe southern rust. It was an irrigated field. And so we had a lot of moisture. So to me, we need to, if we want a lot of southern rust, we need to have above normal precipitation. And then I would be concerned. And if it's warm, then I would be concerned about southern rust. If we're above normal precipitation and cooler than normal, then I would be concerned about northern and maybe tar spot. So, what other questions? Anyone have any other questions? Okay, so these are fungicide trials. I do one fungicide trial at 6 locations in Iowa every year. And basically what I do is I'm comparing different products from different companies. This data is used for another tool with the Crop Protection Network, which is fungicide efficacy, right? And so from these trials, I'm able to say product X is better against southern rust. Product Y is better against tar spot, right? So these are the trials that I'm using for that. In 2025, we lost the trial at Armstrong because they had a derecho come there and wipe it out. So, and then these data that I'm going to show you, I just published on the ICM blog. So if you went to the Iowa State website, even if you just did a Google search with my name and corn fungicides 2025, all this data is going to come up that I'm going to show you now, right?
What's your plot size?
Plot size is 4 rows, and then it ranges from about 40 feet long up to 100 feet long, depending on the farm. But yeah, 4 foot is sprayed, and then. Okay, so these are the products that I looked at this year, and we mostly looked at that R1 application. You'll see in here this product here, Cover XL. Cover XL is a generic quilt XL. And what I wanted to find out in this trial was if you spray a generic product, most of the generic products, first of all, they're cheaper, but they don't really have the efficacy that the name brand products have because they're older chemistry and they just won't last as long, right? And so I wanted to see, can we get away with just spraying a generic at R1 rather than using a name brand product, which is 5 or 6 times more expensive, right? And then, but then because it doesn't last as long, then I also thought, well, even if we went in with 2 applications, that would probably still be cheaper than 1 name brand application, right? And so that's why I have the 2 applications. So that was the big question that I was asking this year, apart from just comparing products. So this is the 4 locations, so Northwest Iowa, Northeast Iowa, the agronomy farm, and then Southeast Iowa. You can see we had the least amount of southern rust in Boone, in the central farm. This gives you an idea of what 8% southern rust looks like. And then at Southeast Research Farm, we had the most southern rust, so up to 50%, and that's what 50% looks like. And so all these bars you can see represent the different products. The stars tell you that there was all of the products controlled southern rust, right? There were a couple in there that didn't do as great, but and then yeah, so they all controlled, and no one product stood out above any other product, right? So this is yield. So once again, you can see basically all of those products predicted yield. And then this is the yield responses, right, across those. So now the different colored bars are the different farms, And then this pink bar that you can see, that's the average yield response across the farms. But so what were we getting, like 15.5 up to 26 bushels per acre yield response. But I think we get stuck on yield responses, and I want us to start thinking about what's our return on investment, right? So sure, I got 26 bushels, but did I make any money by applying that fungicide?
Did you guys do any like timing when the fungicide was sprayed? Because I know we had some people, they went with John Deere, they went in right before Castle, and it appears, and I don't know if you could speak about Southern Rust, but from remember when I talked to you, the earlier they sprayed, the better the control with Southern Rust versus someone like us, we waited till a little bit later, first part of August is when we sprayed fungicide, you know, it got going. I mean, up here wasn't horrible, but is there, have you guys?
So after this data, I'm going to talk about a timing trial that we did. So just talking about the timing. But yeah, I mean, most of these trials were sprayed at R1, maybe a couple of them were sprayed a little bit later. I haven't really dug into that too much. I think if you sprayed anywhere between tassel and R3, you were probably good. Sometimes I worry about spraying too early, that it's not going to take you all the way through grain fill. So, and also it'll depend on your hybrid, right? How susceptible your hybrid was. So there's so many different things to think about. But yeah, I'll show you the timing data. Okay, so if we just look at the yield response, so the Cover XL costs about $5 an acre. That's just product costs, right? And then these are the product costs that I got from the Crop Protection Network, right? So some of you may not have paid that much for your Veltimer or whatever, but this is just kind of averaged across the whole of the US. We collect those prices. And so, I mean, as you can imagine, since most of those products gave us similar yield responses, we got a much better return on investment with using that generic. But one of the things that, before you all go off and start buying generic fungicides, right, let's just talk through this. So the generic I use, like I said, it was called XL. So it contained azoxystrobin and propiconazole. Azoxystrobin is awesome against southern rust. It's very, very good against southern rust. And we know that. We've used it against rust for the last 3 or 4 decades, right? So other generics are not as good against southern rust. So if we had azoxystrobin as a strobilurin, right? So if we had used like pyraclostrobin headline instead of Quadris, we might not have seen the same result against our southern rust. Okay, so we serendipitously we had a generic fungicide that was very good against southern rust, and we had southern rust. If we had tar spot and used this generic, we might not have seen the same response that we saw. So it's important to know what disease you're controlling and then what fungicide that you're going to use to control that disease. Okay? Okay, the best time to spray. So this is where we did our timing. This is our timings, and we've been doing this trial with Whiffles this was our 3rd year now that we've done it. And this was done at the Muscatine Research Farm down in Southeast Iowa, the Northeast Research Farm, and then the Northwest Research Farm just up here at Sutherland. We have 2 hybrids, one that's susceptible to tar spot, one that's resistant to tar spot. And then these are when we apply the fungicide. So at silking, at R3, at dent, and then we have a double application at silking and milk stage, R3, or at milk and dent stage, right? So if we look at the data here, so we'll just start off by going slowly. This is Muscatine. So we have disease severity on that vertical axis. Along the bottom, we have when we sprayed that fungicide. At Muscatine, we had tar spot and southern rust. tar spot was the biggest disease down there, right? And what you can see is this is on the susceptible hybrid because the bars are solid. So we had about 16-17% tar spot when we assessed the trial. And the R1 application, R3 application, R1 plus R3, and R3 plus R5 applications all reduced the amount of disease. R5 was too late. Okay? If we look at the resistant hybrid, okay, first of all, we have less disease, good, because it's supposed to be resistant, but we see exactly the same trend. So an R1 application was good, R3 was good, the best was R1 plus R3, and then R3 plus R5 did okay, but R5 was terrible. If we go to Nashua and look at the data there, and Nashua we only had southern rust, right? But we see the same trend. R1 is good, R3 is good, R1 plus R3 is the best, R5, no, too late to spray. Then if we look at the yields, I did not collect disease data here at Sutherland because I did not know that they had this trial there. So, okay, this is just a summary that we went over already. So if we look at the yield data, so what we'll see is that where we saw significantly greater yields was only on the susceptible hybrid. On the resistant hybrid, there was no statistical difference between the yields, okay, indicating that there wasn't really enough disease on that resistant hybrid to hurt that yield very much. And so by spraying a fungicide, we just, even by protecting it a little bit against that disease, it didn't really give us any more back in yield. And then if we look at the return on investment, so these are the different yield responses on the susceptible. On the resistant, you can see that those yield responses are low. And then if we look at the return on investment, so I didn't tell you, but we sprayed Valtima in this trial. But you can see on the susceptible hybrid, now we're getting a positive return on investment. But by spraying that resistant hybrid, we actually lost money. So what does this mean for you guys, right? I think that this is helpful from your fungicide decision making, right? I don't think that we need to spray fungicide on resistant hybrids here in Iowa. So I think it's a good idea to know what you've planted, right, in your fields. And when you're making your fungicide decisions, you want to spray those fields that are planted with susceptible hybrids first, okay? Those are the fields that you're going to target. And then if the disease is really bad and you're not sleeping at night, then you can go in and spray those resistant hybrids. I don't think you're going to get a return on investment, but you know, maybe on your farm you will. But I think that this data just shows that resistance is working. You don't necessarily have to spray those resistant hybrids with a fungicide.
But the only question, Alison,
Mm-hmm.
your double spray at $57.74.
Yeah.
On the resistant hybrid, you're like 3 cents an acre.
Yeah.
So it's, granted, you might have some data, but it's like,
Yes.
that's not what I would expect. You know, it's
Yeah,
like,
I mean, that's very true. Yeah. I wonder, if we just go back and look at these yields there, it's probably coming from this R1 plus R3. We are getting better yields at all of them on that resistant hybrid with that double application of fungicide.
so then from a farmer
Yep.
standpoint, you know, you're looking at a price,
Mm-hmm.
right? Okay, and generally when I talk to farmers about fungicides, they're trying to decide to buy them in the summertime when we're at a low commodity price.
Yes.
And they're out of money for operating, so it's really challenging sale. But depending upon when you look at that, we have 18 months to market our crops. So generally, we would see a spike in pricing in January and February. So if you have those bushels, that, I'm always about getting bushels.
Yeah,
Try to produce more. So that and trying to figure out, fungicide, moving in and out of your plant, different areas in the fields have different, it's like, to get anything rock solid is really, really hard.
Yeah,
Would you agree?
yeah. Yes. I'll make a joke and say that's why we're in the problem that we're at the moment, right? Because we have too many bushels of corn. That's why our corn is not worth anything.
Right.
So, but
demand is down. Just
yeah. But yeah, I mean, there's a lot of things in here, right? I also know that susceptible hybrids tend to have higher yield potential than a resistant hybrid, right? So I haven't taken that into account. I also know that when you spray a fungicide, your corn is going to stand better. It's going to help you with harvest, right? So there's a lot of factors that I haven't taken into consideration here. But it's just, first of all, like, I'm a little concerned about just fungicides just going out on the landscape, because they can go out on the landscape, right? There's a lot of things that they're affecting that we don't think about, right? And the biggest thing is fungicide resistance, but there are other concerns that we should have, right? So, I don't want to see every acre sprayed with a fungicide. I would rather that those fungicides are used a lot more judiciously. And then the other thing is, I'm not a farmer, but I just think, I would rather, this is what I think, that if I was a farmer, I would rather plant a resistant hybrid and not have to even think about or worry about spraying a fungicide than plant our hybrids and then I'm going to be like, do I spray? Don't I spray? Blah, blah, blah. Now I've got to get the aeroplane. Can the aeroplane get here on time? Oh no, he can't get here this week. He can only get here in 10 days' time. Am I going to lose my crop? All that stress and everything, right? And so, yeah, like I said to someone earlier, this is my opinion, right? And I just hope that I'm giving you guys things to think about, right? But at the end of the day, it's your farm, it's your pocketbook, it's your livelihood, and yeah, so you make the decision that you think is best for you.
Probably the best answer I ever heard to any fungicide question was, it depends. Because
what was the answer?
It depends.
Oh, yes. Yep.
Because depending upon your year and timing and your disease triangle, there's so many variables, like you said, you got to think about all these things when it comes to a fungicide decision. That I know, and I do not envy you guys at all having to make I just go out and spray, right? Because I just collect data, but I still get a salary at the end of the month. Mm-hmm. So I mean, it's not only fungicide anymore, right? It's, okay, am I going to put this biological in the tank? Am I going to put this micronutrient in the tank? Am I going to put this insecticide in here? What about this? I call them magic muties from, company XYZ, right? Am I going to throw that in the tank? And so, I don't envy you guys, but hopefully I give you something to think about. So, any other thoughts? Sure.
The R1, R3, or R1 plus R3, even just get toward the end and you've got that part jug of chemical. Not that I want to run around and do a bunch of partial shields.
Yeah.
But even coming back with a second pass, potentially just with 10-20% of the farm, just to see something, I guess, if it jumps out to me on the yield monitor later.
But hopefully when you do that 10-20% on the farm, you're leaving check strips in the field so you can compare in the field, not field A to field B. You want to compare strips in field A, right? And see, yes, and totally, go ahead. I mean, the other thing about that half jug, it'll keep, right, till next year. As long as you store it somewhere cool and dry in the shade, it's going to keep. A fungicide will keep for a few years. So, yeah, you don't have to use it because it's sitting there.
I've got a question. So
Yes, Eric.
So this is a summary of last year, right?
Yes.
And every year is going to be different.
Different, yep.
So how much weight can you put into data like this when making a decision for next year? How much should it be based on historical data, and how much should it be current weather conditions?
I think the one thing, like this data tells me, and my data from other trials, and just from doing fungicide trials for the last 15 years, is I think it just consistently the best time. And I've tested V5 applications, V12 applications, right? We've done R1 and R3. Consistently, the best time to get that fungicide in is around about R1, right? So remember, you don't want to go before tassel. If you go before tassel, then you have to watch your surfactants, right? Because you don't want to damage your ears. But so from tassel, and then I would say until about, the end of pollination, when those silks turn brown, that's your best window for applying a fungicide. And that's just from all my years of data and from what I've seen. And then from what I've seen from like my colleagues, Darcy in Purdue and Damon in Wisconsin, Marty in Michigan, right? Tamara Jackson out in Nebraska. I mean, we've got several horrible, in-depth academic publications, right, telling us that the best time to apply a fungicide is that R1 window over the last 15 years, right? Even as products have got better, that's still consistently the best time to spray. So
then relying on all those years of data, I'm not asking you for the data show.
Yeah.
Just if you took Alison and you said all those 15 years, would you do a sequential 2-pass application?
No, absolutely not. I would never do a 2-pass application. Yep.
It's like if there was a year it was going to pay off, it was this year. Or it was 2025, right?
Yeah.
You're going to see a response.
Yeah, and we did, right? R1 and R3, it looks great, but it wasn't. Remember, I'm a horrible scientist from the ivory tower, right, who uses statistics. They weren't statistically different. The R1 and the R1 plus 3 were not statistically different. And so, so that R1 application, yeah. And I would never spray twice in Iowa.
And one big factor that you definitely bring up is if you had a high commodity price, it'd make that
Yes.
payment easier. But
Oh,
when
yeah.
you're talking low commodity prices,
Yeah.
a sequential,
Yes.
pretty tough.
Definitely.
To make that go
Yeah,
on.
exactly. Yeah. If you're looking at $3-4 corn,
Right.
you definitely don't. But if you're looking at the $8 corn that Stuart's hoping for.
Oh, right. Sure. Well, he might be a better marketer. Maybe he's doing a better job of it than the rest of us.
Yeah. So this is the last couple of slides. I don't know how we're doing on time. Okay, well, I don't want you guys to get bored either. So these are a lot of tools that that are out there that we've been developing to try and help farmers with their decisions, right? And this is from the Crop Protection Network, really easy to find on Google, right? Lots of different tools. So first of all, there's this tool that I talked about. This is the map, okay? So here we have a map down here. All those red counties are where southern rust was reported, okay? And so if you start looking at this map in July, you'll see some red counties, and then they'll kind of move up, right? And you can just watch where the disease is. This is a table that kind of gives you an idea of whether you need to, when you should spray. Probably the most important thing about this map is that if you see southern rust or gray leaf spot or northern corn leaf blight or tar spot, you can report it, right? So you just click on that, just report it, send a photo. That report comes to me. I look at the report, right? And I look at the photo. And if I'm happy with it, then I will mark that county red. If the photo is cruddy, I will say, Stuart, your photo sucks. Send another photo, okay? And then I'll be able to, and because I'm pretty confident, I can tell from a photo what the disease is, right? And so then I'll just mark that on the map. And then that gives us an idea of where the disease is. And like, I'll do that within 24 hours. So there's that map.
So how many pictures are you getting in the heat of the season, Alison?
Like this year with southern rust, I was getting like 3 or 4 a week. So a lot of people don't know about that tool, right? So they don't know to report it. And yeah, so sometimes it would be an agronom, one of our ISU agronomists who would tell me or whatever. So, but yeah, I'm pretty good with my email, I feel like. So.
But you will put it on that map.
And I put it on that map, yep.
So every time we see it,
yes,
we should be just about forwarding it to you, correct?
Yeah, basically. And I mean, the thing is, like, I don't know what county we're in here, but like once it's been reported in this county, if I turn the county red, you don't need to report it again, right? In that county, it just takes one report to turn the county red.
Okay.
Yeah.
So your map doesn't show severity, it just shows
Nope.
presence in the
Just shows present, doesn't show severity. I can write notes, so you can write notes, you know, like I found this on a couple of plants, or, you know, what the severity is or whatever, and I can write notes in the map, but we won't see it on the map. But it's useful for, like, if we want to go back and do some research and figure out, you know, when the disease came in, or build disease prediction tools and stuff like that, we can go back and look at the weather and things like that. So it's helpful from that point of view. Okay, this is another tool. So did any of you ever use the apps Tar Spotter or Sporecaster for white mold? Did you even know about them? Okay, so these were apps on your phones that we developed, but the company who was developing those apps kind of dissolved and fell away. So we now have all of that data, and all of those apps are now available on the Crop Protection Network. So it's a web-based disease prediction tool, okay? And we don't only have corn and soybean there, we have wheat, we have, I don't know, tomatoes and grapes and other bizarre things as well. But, crud, shucks. So I wanted to be able to show you what the tool looked like, but we'll have to look at it just up here in this little thing. So you can plug in your fields on the tool, okay? And then, so your list of fields is here on the top left for those of you who are online. We're starting in that top left corner. And then you can put in your dates. Then you just run the model, right? And then on the right side of the screen, you'll come up with the disease prediction. And so what will happen, it'll show you like gray leaf spot, you've been at low risk, now medium risk, now you're up to high risk for gray leaf spot. And then, you know, within the next 10 days, the risk is going to go down if we're looking at that top one. So it kind of gives you an idea of what your risk is for that disease. And then you can look at that map, look at your fields and go, oh, I'm at high risk for tar spot, I'm going to spray a fungicide. So the model runs from V10, once your corn gets to V10, I think it is, all the way till R3. That's when you can run the model and see what disease is doing in your field. So on there, we have gray leaf spot, we have tar spot, and we have vomitoxin. And hopefully before the summer starts, we'll also have northern corn leaf blight. But the idea is just to put all these disease prediction tools up there, right? Then the fungicide efficacy tool. So this is a tool where, okay, you've gone into your field, I have tar spot. What am I going to spray for tar spot? You can go into this tool, okay, and you can figure out what is the best fungicide to use for tar spot. Because remember how we talked about with southern rust that the Cover Excel was really good against tar spot. It was excellent against excellent against southern rust. It would have been good against tar spot. Okay, and all of that data that's in this fungicide efficacy tools comes from my fungicide trials and everybody else's fungicide trials around the state. And then every year we go in and update that information. So this page is, these tools are being updated all the time. And I'm going to go back to the disease prediction model because I know some people can get frustrated with prediction models because they can be like, this is useless. It didn't work for me, right? So in the bottom right-hand corner, there's actually a place where you can report back to the people who are designing the model, and they do read it, and they do improve the model based on what you get. You can, maybe you don't like the way the site is set up, so you might think of something else that you want on that site. So they're continually improving it. But also if you think the model sucks on your farm, then you tell someone, right? And someone that will go in and will dig through the data and stuff and try and make the model better. How many of you use a weather app to see what the weather's going to do? Every day, right? How good are the weather apps? Yeah, exactly, right? So, but we still use them every day. So I'm just saying, like, yes, it's our best shot, right? And this is our best shot. And we're continually improving it, just like we're continually improving weather apps, or at least I hope they are. And then we also have the return on investment calculator. So that's where I got my prices for the fungicide. Those prices will be updated this year because we'll be collecting new prices. But there you can just run that and see if it makes sense to you to put a fungicide on, right? So we just in summary, we talked about southern rust and why it was so bad in 2025. Remember, in 2026, we start with a clean slate because that pathogen doesn't survive here. And so, the historic levels of southern rust that we saw in 2025 was because we had susceptible hybrids, which we've never had to deal with southern rust before, right? And so the companies are not really about putting resistant hybrids out here in the Midwest because when is southern rust an issue? So, but we did have some susceptible hybrids out there. We had more inoculum coming here because there were more corn acres in the south and the farmers didn't spray. We had more and stronger winds from the south bringing that inoculum here. The disease arrived here early, so middle of July, just as we were at tasseling. And then we had extremely wet conditions and we had very warm days and nights in July, which just helped that disease to get established. And then once it's established in that canopy, then it can just really start to go gangbusters. Fungicides, we saw they reduced disease, protected yield. The best application timing was that double application at R1 and R3, but it wasn't different than the single application at R1. R5 is too late to spray, and the best return on investment in 2025 was a generic applied at R1 on a susceptible hybrid. But remember that generic that we used was good against the disease that we had, southern rust. And then lastly, we talked about all the tools that are available on the Crop Protection Network. So the ROI calculator, the disease maps, the disease forecasting tools, and then also the fungicide decision tools. So, thanks. We're not at the Crop Advantage series.